Okay, so let's see. Another day, another lesson. All right, so what we got today. Add and subtract complex numbers, multiply and divide complex numbers, classify complex numbers and their properties. So let's go ahead and look at the first thing we need to know about, and that is complex numbers. Consider this number here. So we have 5 plus 2i. Now, 5 is a real number, and the 2i is an imaginary number, or a pure imaginary number. So this is like a number with two terms. So they're not like terms, so we can't just put them together. So we can't have like 7 or 7i or anything like that. So we can't put them together, and that's what we call a complex number. So again, imaginary number is quick review. Let me go ahead and remind you what that is. Oops, what is going on my mouse? So that would be something like a square root of a negative number. That would be an imaginary number. Okay. All right, so moving on. So adding and subtracting complex numbers. So this one should be pretty easy. So pretty much what you do is you follow the same rules of adding like terms. So if you have two terms that are alike, meaning they have the same variable and the same power, which most of them usually will. Here I have one term that is normal, and here I have another one. So these are our constant values or regular numbers. And all we got to do is put them together. So negative 11 plus 9. So negative 11 plus 9. Well, that'd be like 9 minus 11. So the first one would be negative 2. Then the next number we have would be our imaginary portions. In this case here, I have positive 3, and is it a plus, or did I just draw right over the thing? All right, so in this case, it's a plus. So yeah, they're both going to be a positive 3i, positive 2i, just because of the way I made that circle. That's going to make it plus 5i. So plus 5i for that one. And that's pretty much it. See? Told you it wouldn't be that tough. If you already know how to do like terms, shouldn't be any issue. All right, so let's go ahead and do the same with this one. So let's start with our regular numbers, 4 and 7. So 4 plus 7 would be 11. And then for the I, don't forget to take the sign of the sign into consideration for this term. So I minus 5i. So this is like 1i here. So remember, just like any other variable, if there is no number in front of it, then it is considered to be 1. 1 minus 4, I'm sorry, 1 minus 5 is negative 4. And that leaves us with negative 4i. And that's it for that one. Another one down. So let's go ahead and move on to the next thing, and that would be subtracting the complex numbers. So let's go ahead and look at our first number, which is our constant value. So 7 minus 2. So 7 minus 2 is 5. Oh, hold on a minute. Whenever you work with these, you got to also consider the negative. All right, so be careful with that, because it's really easy to forget when your second group is being subtracted. So when you're subtracting the entire second group, really what's happening is you're subtracting everything in there. All right, so let me go ahead and show you what would be going on. So this first term here, we got 7 minus 2i. But here's where it gets a little bit tricky, because now I have a negative, so that'd be negative 2. So we distribute it. We distribute it like we would any other number, or like if you're multiplying it by negative 1. So that'd be negative 2. And then the 6i would also be negative. So you can think of it like distributing a negative, but really what's happening, the real thing that's happening, is you are subtracting that entire group. So that 2 is being subtracted, and that positive 6i is also being subtracted. So both of them are being subtracted, and that's going to allow us to see the actual numbers that these are. So again, it looks like 2 and 6i, but it's actually -2 and -6i. From here, now we go back to using our generalized rules for combining like terms. So in this case, it'd be 7 minus 2. That'd be 5 minus, and then in this case here, I know it's going to be minus because both of those are negative imaginary numbers. So 2 and 6. So put those together. We have 8i in this case here. So 8i, because again, if you have two negative numbers, they are going to combine to make an even bigger negative number. All right, so let's go and do the same thing with this one and take away those parentheses. So 6i, and remember, whenever we see a minus on a group, we got to minus everything in that group. So that's minus 14. And this one here, we have a negative I on the inside right here. So since we're going to have to reverse that sign, that's going to be opposite of a negative. That would be positive, or like negative times negative would make it positive. Because again, we're switching the signs of everything in there. Now don't get carried away, because if you see a plus, excuse me, plus sign here, that would mean we're adding everything in that group. So that'd be plus 5. And since we're adding a negative number, that's going to be minus 3i. There we go. So now we got rid of all the parentheses. Just like evaluating any type of expression, we want to get rid of our parentheses because some of them will change the signs like they did in this part here. All right, so let's go ahead and go through now. So 6 plus 1i would be 7i. 7i minus 3i. So that's our last one. So 7 minus 3 would be 4i. Now, normally we would kind of go down the line, but whenever we're dealing with complex numbers, it has to look like what we looked at before. So we have to have the real number and then the imaginary number. So I'm going to go back and we're going to go putting our real number in there. So in this case, it'd be negative 14 plus 5, which would be, let's see, negative 14 plus 5 would be negative 9. And since the I was positive, we're going to go ahead and put that back in there. So just a quick reminder. Actually, you know what? In this case here, there are two parts like I was saying, and it has to be in this order. So it has to be in that order. So in this case, there is a real part. And then on this part here, this is the imaginary part. Oops, part. So those are the two parts that go into a complex number. And this one's also another weird one because normally when we see something with two terms, we consider those to be two separate numbers. But in this case, you do have two numbers, but two terms, but they count as one number. Yeah, I know. It can be confusing, but yeah, they count as one number. Because, you know, you can have something like if I have a square root of negative 5, you know, plus 4 or something. In a way, these would count as the same number. Which again, I know that's confusing, but just try to stick with it, okay? So again, we got to put them in this order, even though normally we get into that habit of putting whatever we find first, you know, first. So make sure that we do that. Let's go ahead and move on to the next one, which would be multiplying complex numbers. So for multiplying complex numbers, we also have to remember that I squared. So remember from the last chapter, we had the I squared, and that is equal to negative 1. And that is something that is going to happen. So whenever we have a negative 1, we can also change that back the other way, which I don't think we're going to do all that often. But if we end up with any I squares, we can simplify that to just being negative 1. All right, so anytime you multiply, it's going to be kind of the same rules. So for this first one here, we only have one term being multiplied to a group of numbers. So that is a group. we're going to use distributive property the same way we would for most other things. So in this case, 2 times 8 is 16. And we also have I. One term has an I, the other one doesn't. So it's going to stay I. And that takes care of our first term in the group. Now it's time to work on the second term in the group, which in this case is going to be negative 3i. So you would just multiply them the same way, like if it was like instead of I, it was any other number like 2x times negative 3x, right? You would get negative 6, and then your variable. But be careful because you do have a square in this case now. So I have I squared. So I'm gonna go ahead and make another line, negative 6, and then I'm gonna have to change this because now we have I square, and I'm gonna replace that with negative 1. And that's one thing that's a little bit different. So like when we're working with quadratics or terms like this, normally we just sort of leave it as squared. But in this case here, you would replace it. And if you get I cubed or I to the 4th, you would use that chart that we had from the last lesson and replace it with that. All right, now I'm also gonna have to put this in order and switch them so that my real number goes first. So in this case, I have negative 6 times negative 1. Those are my real numbers. And I'm gonna replace it with 6. So 16 would be the next one. So 16i. And again, I just switched the places so that it fits the order, the form of real numbers. And that is it for that one. All right, we're moving along pretty well. I think a lot of this is just sort of, again, basic review. So let me go ahead and move on over here to this one here. So now I have negative I being multiplied to these two terms because they're in a group and we're multiplying the whole group. So negative I times negative 2, so that would be 2i, because a negative times a negative would be a positive. And now we have the next one. So this is a negative times a positive, so that'd be a negative. 10, because this one does not have any coefficients, it has no number in front of it. I squared. There we go. And just like we did for this last one here, we're going to go ahead and replace I squared. And I'm going to switch the terms too. So I'm going to switch the terms first also, because it's going to be multiplied by negative 1. The 2i is over here. So now I'm going to move it to the back, and it's positive. So when I move it, it's going to be it's going to stay a plus or a positive. All right, now from here, let's go ahead and multiply this out so that I get negative times negative, which is going to be positive. And then over here, I get 2i. So again, it has to be in that form where it goes real portion, then the imaginary portion. And I think that's it for this one. I don't see anything else that we need to do. So that's it for this one, I guess. All right, let's go ahead and move on to the next one. And this one looks like we're going to have to use our FOIL method. And I know we've been doing a little bit of factoring, and you probably already know FOIL method. It was covered in Algebra 1, but remember, it just stands for first, outside, inside, and last. So those are the two. Well, we got to multiply each number. So like basically what you're doing is you're multiplying it like a distributive. You're distributing 7 to both of these. And then you have to also have a second group where you distribute the second term from the first group to both of these numbers. So it's kind of like a double distributive. But FOIL is a much easier way. It's easy to remember, and it's easy to, make sure that you go through all the steps without missing any of them. So in this case, let's go ahead and do the first two numbers. So that's 7 times 4. 7 times 4 is 28. 7 times negative I, so that'd be negative 7i. Now our inside numbers, the third step would be our inside number. So this would be I times 4, and that would be 4i. Okay, now I'm going to have to multiply the last number in each of these groups. So that's that's a positive I and negative I, which is going to turn out to be negative. I almost blurted that out a little earlier. So positive times negative is going to be negative. And remember, when we were factoring, you would look at this term here and see what it will become. All right, so let's go ahead and turn this in to, oops, what happened to that? Why is it, oh, okay, I still got the exponent thing on. 28. And then here I have two I numbers, so they're like terms. 4 minus 7 would be negative 3I. And now I have my last term, which is actually, I'm going to have to replace that out because, again, I square equals negative 1. Let me go ahead and put that back in here. I'll put it back in there in just a minute. Let's go ahead and move on to the next one. So that'd be 28 minus 3I plus 1. Now you notice that I have an extra real number now. So I'm going to go ahead and add that back in to the original. So 28 plus 1 becomes 29. And again, I square is equal to negative 1. Put a little bit of space right here. All right, looks like we're going to have to do this again using FOIL. So let's go ahead and do the first two numbers together. So this is 2 and negative 5, so that'd be negative 10. And then the second step would be O, so that's the outside number. So that's 2 times negative 3, so it'd be negative 6. Oops, wrong button. I. Now, third step would be the inside. So these two numbers here. So that's the negative times negative, which is positive. Oops. And then 4 times 5 would be 30. There is one I, so it'll remain as one I. Now I got to multiply the last numbers in both groups. So that'd be negative times negative, which would be positive. And now we need to multiply 4 and 3, so that'd be 12. I squared. Combine our like terms, so so far I only have one real number now. And it looks like I have 30I minus 6. Okay. Oh, wait a minute, hold on. I think I made a mistake here. 4 times 5 would be 20, not 30. Maybe I pushed the wrong button again, I don't know. But that should have been 20. All right, yeah, and if you notice anything's weird, just stop and take a step back. There's nothing really wrong with checking your own work. All right, so plus 12, and then I squared is going to be replaced with negative 1. So that's going to be taken out and replaced with negative 1. Negative 10 plus 14I. Well, in this case, it would change to a negative because it used to be a positive 12, but times it by negative 1, then you're going to get negative 12. And now that makes a second real number. So 10 and 12, that would be 22. But since they're both negative, it's going to make a bigger negative number. And then here we end up with plus 14I again. And that's going to be our simplified form of that complex number. All right, it looks okay. So let's get ready to move on to the next one. And I think this is another multiplying one. Okay. All right, so in this case here, we have a square number. Well, actually, this would be a perfect square trinomial. So I'm going to just go ahead and expand it out. oops, 2i, 6 minus 2i, oops. And if I expand it out, now you don't really need to do this, but it makes using the FOIL method a lot easier because now I can see that I have 2 6's in the front, so that'd be 36. And I have 6 times -2, which would be -12i. And the inside terms here are kind of the same thing because it's -2 times +6, so that'd be -12i. And then the last number would be negative times negative, which would be positive. 2 times 2 is 4, and I squared. And there is kind of an easy way to do this, a shortcut way of doing this, but you know, just writing the whole thing out and using regular FOIL is probably going to be just as easy and a little bit. Well, you're not using a whole lot of extra time, and it's just easier to remember, easier to work with if you're used to that. All right, so let's go ahead and put these together. 12 and 12 would be 24, but they're both negative, so it's going to be -12i. And when you add numbers with variables, the variable power does not increase. So sometimes I might get students that'll put a square there or whatever. And over here I get 4i squared. So I'm going to put 4 and then I squared. Replace that I squared with a -1. And it should be here again, but I don't have that there. It's just, I guess I should add that into slides the way it should be. All right, so now I got 36 minus 24i. Oops, missed the 4. Minus 4, because now I have to multiply 4 times -1, and that'd be -4. And then 32 minus 24i. And that's the actual last step. I'm going to put it a little bit further out just so it's a little bit easier to tell that that is our actual answer now. I knew this was going to have a few extra steps in it, so I didn't write the double space between the lines. Okay, so let's see what we have here. It looks like we actually have a combination of multiply. So we got to multiply these two groups here. And then when we're done, it looks like we may have to add this, well, subtract it in this case. So let's go ahead and use our FOIL method. So this is going to be 1 times 9. Outside numbers, so that's 1 times 3i, so plus 3i. Inside numbers here, so 7 times 9, that'd be 63i. Let me just double check that on my calculator. 7 times 9 is 63. Okay, just because I somehow made a mistake on it and put 30 on one of those other ones when it should have been 20. I think it was just pushing the wrong button, I think. All right, let's see. 7i times 3i, and they're both positive, so that's positive 21i squared. Now, at the same time here, I'm going to get rid of these second set of parentheses, -4 minus 2i, because again, we got to switch both of the signs. We have +4, +2i, but since we're subtracting it, that means we're subtracting both of these things. And since we're subtracting them, that means we should give them their sign, so that's a lot easier to work with. Okay, a little bit easier to work with on that here. All right, so move over to the next one. So that takes care of all of what we have there. Now, let's combine our like terms. And we do have that I squared, but I think I'm gonna have to save that one for another one. So let's look at our real numbers. So we got 9, -4. 9 and -4 are the ones we have right now. So that'd be 5. And now for the imaginary numbers, so 3 plus 63 minus 2. So in this case, that would be 64i. Oops, forgot the plus sign here, plus 64i. So let's see, that's 66 minus 4. Wait, 66 minus 4? 66 minus 4. Oh, minus 2i, sorry. For a second there, I thought I was looking at this one here. I was like, wait, should they be 62? No, it's 64. I had it right the first time. Okay, now that takes care of this number, this number, this number, this number, this number, but we still have this one here with the I square. So that'd be plus 21, and then I replace I square with -1. Oops. 5 plus 64, I plus, well, in this case, we're going to have to reverse that sign, so it's going to be -21. And then from here, 5 minus 21, so 5 minus 21 would be -16 plus 64i. And I think that's it for that one. Again, I'm going to put a little space there just so that way we can tell that it would be the answer, right? That way we know it's the answer. Now we should box this. Excuse me, my mouse is not working. The mouse in thingy I usually use is not working, so I'm just gonna have to use the one that comes on the computer. I probably should check it, make sure it's plugged in or something, but oh well, we're almost already, well, we're about halfway done now. And now there has been, again, a small error in the packet. The wrong page was printed out. So you probably may or may not see this next part here. But I guess we're gonna go ahead and cover it just because it's part of the lesson. And that would have only been like, I think we're at 30 minutes or so right now. So I might go back and make this up again, but we only have 1, 2, 3, 4, 5 pages, and then we'll be done. And again, most of this is going to go by pretty easily and stuff like that. So let's just go ahead and keep doing what we're doing. So 8 times 8, because we use our FOIL method, that's the first number, and that's 64. Now, outside number is going to be 8 times -i, so that's going to be -8i. Third step and third term here is going to be I times 8, so it's going to be plus 8i. And last terms of both groups, so that's going to be negative times positive, which is going to be negative I square. Okay, now, what was that about? Okay, well, what does it mean when it says conjugate? So it says two complex numbers in the form of a plus bi and a minus bi are called complex conjugates. The product, which means we multiply them, so when you multiply them, two conjugates always is a real number. So in this case, if we look at what we have here, we have -8i plus 8i. Well, that would be 0i. Which in this case means it's gone. So, right, if you don't have any of it, you don't need to mention it. So, well, maybe for now, I'm just gonna go ahead and leave it in there, but you don't really need to leave it in there. Now we got a minus I squared, but remember that I squared is -1. So since we're minusing a negative, right, when you take away a negative, that's like taking away something bad. So if you have pain and you take it away, that's good. So it becomes a positive. So in this case, I have 64 plus 1, which would be 65. And now it becomes a real number. There is no more imaginary parts on this number. Since there's no more imaginary part, it's not a complex number. It's going to be a real number. So real number like 65 is a number you've been using for a long time, right? You've probably been using the number 65 for many, many years now, probably, 10, 12, or 14 years or whatever by now. Anyway, let's go ahead and get to this next one here. So 5 times 5 is 25. Outside number, so that's going to be 5 times 4i. So it's going to be, make sure I get this one right, 20i. And then the inside number, -4i times 5. So my inside numbers here and here, it's going to be -20i. And 4 times -4 is -16i. And then since it's 2 i's, that's going to be multiplied to I square. And we run into the same thing. we got 0i. And I'm going to go ahead and put in -1 substituted for I squared. So there you go. Now that changes to -16 times -1. And I'm going to ignore that 0, right? So we don't need that 0 anymore. Oops, give me 5. Not. And that will become 25 plus 16. So that'd be 35 plus 6. That'd be 35 plus 6 would be 41. Oops, next line actually. So 41 would be our final answer for this one here. So simplified form of that number would be 41. And in this case, I thought it was going to take a little bit more space than the other one, but I could move. Oops, I could move these apart. Oops, now I'm ruining it. I could make it so that it kind of matches the other one. So if I was writing with enough space to show you each of the steps, that's what it would look like. It'd look a lot like the other one. All right, and again, that was pretty easy, but that's what it means. So conjugates just means that if you multiply them together, you might end up with a real number again. Okay, so next one's going to be division. So dividing complex numbers. Now, there's kind of a rule with this one, and that is I cannot be in the denominator of a complex number. What does denominator mean? So if you remember fractions, that means the bottom number. So this means I cannot be in the bottom number. If the denominator is a monomial, multiply the top and the bottom by I. If the denominator is a binomial, multiply top and bottom by the conjugates. That's why we had the conjugate covered in the last slide, was because sometimes you need that conjugate. So, okay, well, what does this mean? So let's go ahead and times this by I. So I times it by I, the top, and I'm going to times the bottom by I. So multiply both of them, and we end up with 10i over 2i squared. And it's a fraction, so, got to have the fraction bar. Now, why we did that, because remember, again, I cannot be on the bottom. The variable I cannot be on the bottom. So we end up with 10i over 2 times -1. There we go. So go from here to there, and again, I squared. Since we multiply it by I squared, that's going to turn it into a real number of -1. So there should not be any more. I numbers on the bottom, so that'd be -2. Now, in this case here, we can divide 10 by -2. Can be done, so let's go ahead and do that. So our final answer in this case would be, well, I think it'd be -5i, because again, 10 divided by -2 is -5. Since the I is on the top, it basically becomes its own term, so we just get -5i. So this, in this case, would be our real number. So we end up with a real number solution. There you go. All right, so for this one here, I'm going to do the same thing. I'm going to just multiply both of these numbers by I. And I get 4i over -9i squared. And I just clean up this to make it look more like a fraction. Put a fraction bar in here. Yeah. Okay, make sure I didn't miss anything. And then I'm going to work sideways here. So I get 4i over -9 times -1. So again, just replace the I I square with -1, so that way it becomes a real number, so we're not dealing with that imaginary number anymore. And then here I'm going to have 4i over, see 9, well they're both negatives, so that'd be just 9. So that would just make that plain old 9. In fact, actually, I don't think there is anything else that we need to do with this, because I don't see anything that is, I don't see anything more we need to do. So I think this is actually going to be the end of this one. So let's go ahead and I'm going to box this one up, just because I had a little bit of work to do. Make sure that I'm going to box this one up, even though I haven't been doing that. All right, there we go. So that's it for that one. Let's go ahead and move on to the next one. I can't divide 4 by 9, so I'm pretty sure that it would have to stay like that, which sometimes it stays as a fraction. Sometimes it can be a whole number. Sometimes it'll have to stay as a fraction. All right, so I'm going to bring that back because I need to times both my top and bottom by I. And while I'm at it, I'm going to do the same to this one right here. That way I don't have to, do a whole lot. So let's go ahead and remember, a fraction bar is a grouping symbol. So you treat it like it's a parenthesis. What do I mean by that? Well, if I were to draw a parenthesis around the 28 and the -8, it would be distributive property. So I'd end up with 28i minus 8i squared. So both of these numbers got multiplied by I. Now I'm going to have to also do the same thing to the bottom. So this would be 4i squared. There you go. And I'm going to go ahead and keep it as a fraction. Okay, so now let's see what we can do, because again, we do need to get rid of that I minus 8i squared, so this would be -1. Now remember, anytime we see an I squared, we replace it with -1. Now I'm going to do a little bit of a shortcut here. Well, maybe I should, maybe I shouldn't. You know what? I'm not going to. I could have, if it wasn't for that top one. So because I have to take care of it here, it doesn't really matter. I'm just going to do the same with the bottom one here. So 28 plus 8, because now I changed that top number to a +8. Oops, almost forgot the I here. Just looking over it as I'm doing the work. And now my bottom number is -4. And now I really should check to make sure that I don't have anything that is, I don't have anything that any more I can do. So I need to divide it, which in this case, it looks like I will need to divide it. So I'm actually going to do two things here. I need to divide 28i by 4 and 8 by -4. Well, both of them would be divided by -4. But I'm also going to switch where the I is. So remember, we want this to be a regular form, which means the regular number goes first. In this case, 8 is my regular number. So 8 divided by -4. So 8 divided by 4 would be 2. But again, being negative, it's going to have to switch to a negative number. Now, 28i is the second part. 28 divided by -4 would be 7, but it'd be -7. But I got to bring that I back, so it would be -7i. So again, I knew that something like this was going to happen, so I just had to make sure that everything was covered. Okay, so let's go ahead and do the next one. So same thing, we're gonna have to treat this like it's a group. So -8 times I, so that's -8i, minus, and then here I have 2i, so that would be 2i squared. Oops, that one didn't go out. Hasn't come out squared. There we go. Now it's a square number. And my bottom number is going to be 6i also squared. Come on. There we go. And I'm going to line it up just so it looks more like a regular fraction. There we go. Now we got to simplify this. Now, I'm going to kind of take a bit of a shortcut here. So again, we know that anytime you see an I square, we replace it with -1. But remember, multiplying anything by -1 is just going to switch the sign. So, okay, nothing's happening to this -8i, so it stays. And all I'm going to do is just change this. So it just becomes 2i. Or, I'm sorry, -2i becomes just +2. And this is going to be -6. So it's going to switch the sign. So you notice again, it goes from here, becomes -1, and then switches the sign. But you can also go from here to here, but just by switching the negative to a positive. And if you look here, switches this positive to a negative. So that's kind of a shortcut, you know, but you're only saving yourself a little bit of writing. And in this case here, I'm doing this because I think I'm gonna have to do some division. Now, just like any fraction, remember, if you have a fraction that you can't divide, like in this case, I cannot divide 8 by 6, you should check to see if you can simplify it. But this one's a weird fraction because I have two numbers on the top. I have -8i and 2. So you simplify it the same way you would any other fraction, but all three of those numbers, so the 2 on top, 1 on bottom, they can all be divided by 2. So 8, 2, and 6 can all be divided by 2. So that's what I'm going to do. I'm going to divide all of them by 2. There we go. So I think I divided them all by 2. Now there's also something else going on here, and that is it is not in complex form. And I think that's just one really quick thing to do right now. So I just got to switch that top number so that it goes 1 minus 4i, and the bottom can stay -3. There we go. So I think that is it for that one. Another one done, another one down. Oops, and again, just because now we're working with stuff that's a little bit more complicated, I'm gonna go ahead and box it. I usually box everything that I want to send out as my answer, but I just, I didn't do that to the early ones, just because it's the last thing you do, but here it's a little bit more complicated because, you know, it's like which one of these could be the answer. All right, let's, we only got 2 more to go, so let's get things staying moving. Oh man. All right, so this one might not be that different. It looks like we're gonna have to multiply these by I again. Okay, but now we're working with the I on the bottom number. So top number in this case, we only have one thing. We only have -2 times I, so that's gonna be -2i. The bottom one is gonna be a little bit tougher though because, well, we got 2 things going on. All right, so if there's 2 things on the bottom, how do we get rid of it? And this is where multiplying the conjugate comes in handy. So before I do that, I am going to have to, I wonder if I can just, okay, just so I don't have to type the whole thing out again. What I'm gonna do is I'm gonna switch this. So instead of I square, it's gonna be -1. But I'm also gonna simplify that because again, we already know that opposite of -1 or double negative here is just gonna become +1. So now we have much smaller numbers to work with. Okay, now I should also switch these two. on the bottom. So instead of, there we go. And switch to the bottom number. So I'm going to get 1 plus 5i. Just move the 1 over to this side here. And now, finally, we're going to have to get to the part that is going to be the complicated part. We are going to have to find out what the conjugate is. So if you look at the conjugates we've already been working with, you'll notice that they're the exact same terms, 8 and I, 8 and I. But there is one difference, and that is one is a plus, the other is a minus. 5 and 4i, 5 and 4i. The only thing that's different is that one is a plus, the other is a minus. So this is a pretty good way of finding out which one it's going to be. So again, it tells you right here, a plus bi, a minus bi. So again, same terms, just a different sign. So let's go ahead and multiply our top number and our bottom number. So what are these numbers going to be? Now, just like simplifying, when you simplify, you divide both things by the same number, and that keeps the fraction value the same. When you're multiplying it, it's like the opposite of simplifying. You're making the numbers bigger, but it's actually not changing what the number means. So you might be thinking, okay, well, when you multiply it, you're making both numbers bigger, but that's not actually what's going on. Anyway, let's get back to the conjugate. So same terms, 1 and 5i, 1 and 5i, but one is plus, the other is a minus. Oops, sorry, I said 1 plus and 1 minus. But when we're doing this, we're going to have to make them both the same. So this means I'm going to have to multiply both of them by this number here. So times, or we could just put a dot there. That might be a little bit easier. I don't know. But I already have the parenthesis there, so it's not going to really do anything. All right, so let's go ahead and multiply our top number using distributive. So that's going to be negative 2i. And then time to multiply the second one. So that'd be negative 2i times 5i. So negative times negative is positive. I times I will be I squared. And that's our new top number. Let's see what our new bottom number is going to be. And it looks like we're going to have to use FOIL. So use our FOIL technique. Even though there's no parenthesis here, you still treat it like it's in a group. So that's going to be 1i. And then here we have minus 5i plus 5i, because outside, inside. Now it's time for the last number. Looks like we have 5i times negative 5i. That would be negative 25i. Now, just to make this fraction a little bit more balanced, I'm going to go ahead and straighten it up a little bit. Okay. Negative 2i. And again, I'm just gonna switch the sign. I'm gonna kind of take that shortcut because these are, you can already tell it's being quite a bit of work. So I'm just gonna switch the sign, and that takes care of the I squared. All right, so let's look at the bottom one. So we have 1, and next term would be negative 5i plus 5i. That would be 0i. So that term cancels out, drops out, no more of it. Plus 25, because again, well, actually this should be an I square. I seem to have missed that. Oops, wrong place. There you go. It should look like that. Okay. Now, that looks a lot better. All right, so I just gotta clean this up a bit more. Let's see. I'm gonna have to switch my top numbers because again, it's gotta be in that right form, and my bottom numbers, combine those so that I get 26. Now with this here, we do have a bit of a, we do have one more thing we need to do. It looks like I'm running out of space. I'm gonna move all these up because I got one last thing I need to do, and that is to simplify this fraction. So 10, 2, and 26 are all even numbers, which means I'm going to divide all of them by 2. So it's going to be -5 minus I, because everything got divided by 2, over 13, because again, that's divided by 2 now again. And there we go. That is going to be the final touch. We made it. So again, there's a lot of steps in this one. It's not really, I don't think it's really like confusing to the point of, you know, how did you get from this step to this step? We've been covering a lot of this stuff, but now we're just bringing it all together. We're kind of using every step that we've used up until now. Okay, so, let's go ahead and move to this one here. So I got 5i squared. Oops, the square didn't go through. There we go. And then 6i, and then 2i squared. And then here it should be a plus. And I'm gonna clean this up to make it look more fraction-like, because usually when we write fractions, they're both centered. You know, I should have wrote this up here, right? So that way we can see what our first step would be. And again, I'm gonna just move this here. So this should be our next step. Oops, wrong grabby. There we go. And I'm gonna just clean this up. So get rid of that 5i square and just turn it with -5. Oops, automatically turned that thing on. Why did it do that? So again, quick shortcut, just get rid of that. So we have 2i squared. So just replace it with -2. And that's it for that. Actually, you know, I'm going to shorten this up a little bit. Now we're also going to have to I'm also going to switch these bottom things. Oh, come on. Switch these two bottom things. So instead of 6i minus 2, I'm going to go with -2 plus 6i, and then delete this. So I just switched the place of those two things. And now I'm going to have to come up with something to make it work out. At this point, we are going to need the conjugate. So what can I do to get rid of this here? So I'm going to need to multiply. So my bottom number, I need to multiply that by -2 minus 6i on top and bottom. Now I can multiply them out. To change this back, and then multiply -5 times both of these, so that'd be 10 plus, and then 5 times 6. Now that's going to be 30i. And for the bottom here, I'm going to have 4, because -2 times -2. And I'm just going to kind of go quickly through this, just so that way we have it in our head. Okay, and just going to have to trust me on the math on this one here, hopefully. Or actually, you know what? Don't trust me. Check it over, make sure nothing's missing. I'm going to move it over just so I have some more space to write this if I need to. And now I'm going to get rid of all of the extra signs. So that's going to be plus 30i. There's nothing weird about that top part. Okay, now for the bottom part here, let's see what we got. We got 4 plus 36. Because those I, the 12i and negative 12i, that's going to cancel each other out. And this 36 is going to become I plus 36. Because again, that I square is just going to reverse the sign. And actually, in this case, there's only one last thing to do. Okay, well, I don't know why it's way out of there. Looks like I'm just going to have to get rid of it and make a new one. And then all I have to do is add 36 and 40 together. I'm sorry, 36 and 4 together to make 40. And oops, looks like we're going to have to simplify that. So 10, 30, and 40 are all divisible by 10. So it looks like I'm going to have to divide everything by 10. So that's going to be 10 plus 3i over, and then 40 divided by 10 would be 4. And there's our final answer for that one. And I think that's it for today. So yeah. And again, there's been an error on the packet, so this page doesn't show up. But again, I might include it in next week's packet or maybe not. We'll see what happens, but you know, it is what it is. We covered it. So, you know, no one will say I didn't. And with the homework for this one here, I think the homework actually does not go with it. I don't have any copies of the packet for this week, like the ones I sent out, because you know I know what I tried to send out, but that's not actually what was sent out. And I think that that second page has nothing to do with it, so I'm just going to go ahead and give full points on all of those. Anything that just comes back to me, I'm just going to go ahead and give it full points because it's not even related to that. So I guess if you want to, you can try it, but I think when I looked at it this morning, it didn't even have any directions on it. So it's like, what are we supposed to do with it? So it's just a bunch of problems with no directions. So yeah, that's why I decided to just say whatever, you know, whatever happens. Anyway, that's going to be it for today. So that's it for this week as well. So that will be it for today. Bye-bye.